I bought this amplifier off of eBay for $90 a few months ago, um, like 4 or 5 months ago, and it worked great for a while. But then it developed a really god awful buzz. Here is a video taken on April 23rd when it first started. Starts to do it again. Boy, that's bad. That's really bad. So I've got everything unplugged. All the knobs are down. If you power cycle it, it'll go away. So I turn it off, turn it back on, and then you can play it. It comes back. Okay, so I took this amp apart, and this is kind of interesting. The main power amplifier is this single chip here, which costs maybe $6 or $7. It's a TA, I don't remember the number, 29, I think it's TA 7294. I'm not sure, I forget. Alright, I went and found the datasheet for the TDA 7294. Here it is. It's being sold as a 100-watt audio amplifier, and to the right there you see a little picture of what it looks like, and they have two styles that you can purchase. Here's the pinout. What caught my eye here is that you've got a mute input and you've got a standby input. The standby probably just cuts the power supply to minimal. The mute is self-explanatory. So it's kind of interesting. If you want to modify your amplifier to have either a standby or a mute input, should be pretty easy to do if you want. Now, looking at the datasheet, they list the power levels as 100 watts for quote-unquote music power, 70 watts for low distortion power, but that's at plus and minus 35 for the input DC voltage, so that's a plus 70 volts input. It does work up to a maximum of plus and minus 40 volts, but the Orange Crush RT 35 RT actually runs this at lower than that at a total, I measured something like 58 or 59 volts across. So I'll call it, plus and minus 29 volts. So they've derated the input power supply by a good amount, more than 10%, which is a really great design approach to keep the amplifier from getting too hot. Now, the output power will drop, but if you notice, when you buy the Orange Crush 35 RT, it's sold as a 35-watt RMS amplifier anyway. Yeah, good design approach. The chips are going to last longer statistically across production lines. And of course, power dissipation will drop by the square of the voltage. So, a small drop in voltage is actually a pretty good drop in power dissipation. So, great approach. So this is probably a great amplifier that should last a long time. Originally, I thought maybe this would have had a switching power supply. It doesn't. It clearly has a nice big fat transformer, and then your secondary is here. Back here is a full wave bridge rectifier. Then you've got these two capacitors. On each capacitor, I think, says 37 volts, and you get a total of 60 volts supplied to this chip here to provide the 35 watts, I think, is the rating. But if you look at the data sheet, it's listed as a 100-watt amplifier. Over here are plus and minus 15 volts for these kind of garden variety, really old op amps, like from the 1980s. Like I think it's TL072. That's like a super old op amp. I think it's like some kind of JFET input. I'll have to check. I don't remember off the top of my head. It's been a long time. Okay, so here comes the problem. And I'll just zoom in. Now, when the noise first came, I thought the amplifier was dying. I assumed that the power supply was nothing more than these capacitors getting filtered and being fed directly to here. So there was not much to fail. I sprayed the amplifier with cold spray, really good, and it didn't get rid of the sound. And then I tried this little guy here, which I think is the negative. It's a 7915, negative 15 volts. So all I have to do is spray just this guy right here, right on its tab, and it goes away. And it stays that way for a little while. So I might actually be able to get away with putting a heatsink on that, but maybe it might be better just to replace it.
Although I was pretty much convinced that the IC itself was just bad, I went ahead and checked the data sheet, checked a few things off of that, particularly the voltage being fed into the input of the 7915. And then I went ahead, after that looked okay, I went ahead and connected up my voltmeter and my oscilloscope to monitor the voltage output, the negative 15 volts out that feeds all the op amps. And then I just waited to observe what that looks like when it fails.
It was screaming just a minute ago, and I shot cold spray onto the 7915, but the voltage on its output is only 7.5 after I sprayed the cold spray. So that chip is definitely bad. The meter on the left, that's the input voltage, and that shouldn't exceed 35 volts. So far, I've not seen that. It's always stayed right around where you see it now, negative 29 volts. But although it's quiet, this amp I wouldn't expect it to work too well if the rail on the op amps, one side of it is only 6 volts and the other side is 15. The ripple is higher than it was. Here we go, it's starting up. You can see the ripple suddenly getting worse. Now it's going nuts. So that's a 200 millivolts peak to peak, so I see about roughly eyeballing it, maybe at least two divisions, 2.5 divisions. So that's about half a volt of this triangle wave that you see here. And the output voltage has now fallen down to about 3.3 volts. And it'll just continue to get worse and worse. Right. More.
Okay, so now before I put everything together, I went ahead and did this quick test using my current limited power supply on the bench. I set the current limit to about 50 milliamps. Then I connected the power supply to the input of the LM7915, and then I connected 2 voltage meters to the input and the output to observe voltage regulation. And with the current limit, that will just prevent any catastrophe if there was something wrong that would fry the circuits and just destroy all the work that I've put into it thus far. Got the voltage turned down. I'm unplugged here. Okay, so now I'm going to plug in power. And I believe that's the input. That's the output. That's the current. And that's also the input. So I slowly raise the voltage input. So we've got about 1.3 on the input, nothing on the output, because you got to overcome its dropout. So once we get past that, we start getting some voltage feeding out, very little current. We're about 10 milliamps, 20 milliamps, 30 milliamps now. Then bring it up very slowly, nothing really bad. And so we're at negative 20 volts on the input. It's regulating to the negative 15 as it should be. The current is very low, 30 milliamps. All right, so it looks like everything is working as it should be working. Okay. Yes. Okay, it looks like I have it working. And my cat also seems to enjoy my amplifier. Her name is Chloe. I did leave the amplifier on overnight, and it's still running. and I don't really expect any failures from it, so it'll probably last a really good long time. Thanks for watching.